Hello everyone, I'm Lian Liu. I'd like to summarize the work I did in assignment 2. My research topic is the tensile test of high-toughness pipeline steels. The presentation involves 3 parts, which are introduction, literature review, and research design. What is pipeline? Pipeline steel could be made for the pipe, which is the transportation of goods or material. The pipeline steel could be divided into a number of steps, which has been listed in the table. As we can see that the different grades of the pipeline steel consist of different percentage of metallic element and different strengths. Why we select the pipeline steels as the research topic? The main reason is that the more and more submarine oil and gas pipelines have been installed with the development of offshore oil and gas. In some developing countries, almost all the steel pipes of submarine pipelines need to importing because the quality requirement for the comprehensive properties, such as the resistance to pressure, anti-corrosion, and so on. The second reason is that the satisfying the requirement of engineering operations, such as the weldability. There is a heightened tendency towards the addition of properties such as a high strength capacity. Furthermore, the need to meeting the higher strength with high ductility and toughness has pushed the improvement of the high strength steels to work in a harsher environment. Before I start the research, I have finished the literature review to realize the relative knowledges. There was a series of tests conducted by Shin in 2007. They conducted a various type of tensile testing to study the tensile properties and the microstructures in high toughness pipeline steels. The researchers selected the API engg851 and the engg851 grade pipeline steels as the specimens in order to convenience in record results. The engg851 specimens are divided into single-phase and two-phase regions. They are named as A and B sample respectively. The engg851 specimens was named as C in the single phase. The specimens were measured in room temperature conditions and the tensile speed was set as 5 mm per minute. The optical technique and the scanning electron microscopy was used to observe the microstructures of the specimens. The results has been achieved. The finding illustrates that the two phases engg851 specimens has lower yield and strength than the other one. By contrast, the elongation of single-phase engg851 was lower than two-phase engg851 specimens. As for the single-phase engg851 steel, it has higher yield and strength than the two kinds of engg851 specimens. However, engg851 specimen has lower elongation. The interesting point is that the yield ratio of the three kinds of specimens are similar. A similar study conducted by Yang, who researched a various shape of pipeline pipes, including the submerged arc-welded pipes, which are consisted of steel plates made by JCOE and the UOE forming process. The specimens for tensile test were cut at 12 and 3 of the clock position and the longitudinal direction. Moreover, the test samples were divided into transverse weld strip, longitudinal metal strip, and transverse metal strip. The tensile test was expected to measure the ultimate tensile stress, yield stress, and other properties in the room temperature. There were 39 tensile samples of JCOE and 18 UE samples. The results of tensor tests have been illustrated in the table. The previous research could outline the existing technologies and show my ability to select pertinent information. Locate my research topic in the context of the previous study. Create a research for my study and identify a gap in the current research. After review the previous research, I designed the research for my topic. Firstly, what is the question I will study? The main question is that whether or not the geometry and the type of the pipe influence the mechanic properties of the pipeline steels. Therefore, I selected three types of pipeline steels, which are X70, X80, and X100 to investigate the relationship between the type, geometry of specimen and stress-strain behavior, yield strength, ultimate tensile strength, and yield-to-tensile ratio. The experimental samples could be divided into two groups which made up of one row, and three modified strips were cut parallel to sample longitudinal direction from each type of pipe. The cross-section of each strip specimen was 8x8, 8x6, and 8x4 respectively. The tensor testing was conducted at three temperature conditions, which are room temperature, 40-degree temperature, and minus 40-degree temperature, and applying universal testing equipment. To design three temperature conditions is in order to assess the tensile properties under the different environment. The yield strength, ultimate tensile strength, and the yield-to-tensile ratio at 0.2% and 0.5% offset could be compared by drawing the stress-strain curves. Moreover, the reduction and the elongation would be assessed and compared. In order to evaluate the mechanical properties of all weld metals, a series of tensile testing were designed on the pipe double submerged arc welding, produced from APL engg851 pipeline steel. The specimens selected one round bar, one split strip, and one full section strip. Then the tensile testing was conducted at three temperature conditions, which are room temperature, 40-degree temperature, and minus 40-degree temperature respectively, and set the tensile speed as 5 mm per minute. The yield strength at the 0.2% and the 0.5 offset were determined by plotting the stress-strain curves. The ultimate tensile strength and the yield-to-tensile ratio also could be obtained with the assessment of elongation. Lastly, the result of the series of tensile testing were observed by metallographic technique. The optical and the scanning electron microscopy would be used to assessment of the specimens by characterize the microstructure. There are some advantages. From my research, I achieved three data about the mechanical properties of three grades of pipeline steels with different shape and size. It provides enough information allow us to realize the pipeline steels. Besides, the test conducted in three different temperature conditions. It studied the properties in different environments. Lastly, I observed the result of tensile from microstructure angle. In fact, there are a number of limitations among the research design. Firstly, the both tensile testing were conducted in touch with air directly. However, the realistic situation in the transportation of gas and oil is that almost pipes work underground or water rather than touch with air directly. Therefore, the result of the tensor testing could not reflect the realistic situation. Secondly, the effect of residual stress was not considered. The residual stress has effects on the acceptance criteria. Lastly, the temperature conditions are set as 3 fixed temperatures. The result would be more reliable if the tensor testing was carried out with the change of temperature conditions. That's all what I want to present. Thank you for your attention.